All right, so today's lab is an equilibrium lab, which we haven't started the equilibrium chapter, but we've seen some equations that have to do with equilibrium. And as you guys kind of read through this, we know we're dealing with hydrochloric acid, which we know is what kind of an acid? Strong acid, right? It's a strong acid. And then acetic acid is a what kind of acid? Weak, yeah, it's not one of the 7 we memorized, right? So the weak acids have to have what kind of arrow? Double-headed, right? So equilibrium, the next chapter, is all about those kind of arrows. And those kind of reactions are where you start out with acetic acid and then it breaks apart, but it can also reform acetic acid. It can go back and forth. And the equilibrium part of it is figuring out how much of it breaks down or how much of it stays together when it reaches equilibrium, when the reaction not necessarily stops, but when it stops having a net change, when it kind of as much breaks down as reforms. We all would think of it as normally just being 50%, right? Maybe half of it breaks down. But there's actual equations we'll figure out where in some reactions, most of it doesn't break down. Most of it stays together, all right? So with today's lab, we're going to kind of explore that topic real light and easy with just a comparison, so it'll be kind of nice. So the first thing we're going to do is we're going to have hydrochloric acid, which is our strong acid. All right, so this is strong. We have acetic acid, which is going to be our weak. We know the strong acids, they're going to have a single arrow. We know the weak ones will have some kind of double-headed arrow. And we also know that we can check the chart to see which one's bigger, right? Which is it larger going in the forward reaction or is it larger going in the reverse reaction? And when we get into equilibrium, we'll understand more about what that means. But today we're basically going to compare 1 molar acetic acid with 1 molar hydrochloric acid and see if they're the same strength. They both have the number 1 in them, right? They're both 1 molar, but which one do you think is going to be stronger? HCl, right? Because it's the strong acid. We're actually, spoiler alert, yeah, that's true. We're going to try to figure out which one of these pairs up with the 1 molar acetic acid, meaning we can kind of figure out how weak acetic acid is, comparing it with all of these different hydrochloric acids. So the other thing we're going to do is we start off with 1. To get it to 0.1, we're going to dilute it, right? And then we're going to dilute it again. We'll dilute it again. We've done this before in lab, so we're going to do a dilution here, and that'll help us figure it out. Now, how are we going to visualize their comparison? We're going to do it 2 ways, and I just added this morning because I thought, why not? Universal looks cool. Let's check it out. The first way that we're going to do it is with a conductivity meter. So we're going to see how much they conduct electricity. And the assumption would be that this would conduct the electricity the most, this will conduct the electricity the least, all right? Because this is the strongest. Now we'll find out if that's true or not. And then we'll also have a number here, or we'll have a word describing its conductivity, and then we can compare them over here. Then we'll put a couple drops of universal into all of them, and a couple drops of universal into here, and see if it also agrees, if it lines up with the same one based on color. So we'll look at this based on conductivity and also pH in a way, because we're going to be looking at the universal indicator, which will give us kind of the pH range for it. So that's kind of what we're doing overall today. To get our data for the conductivity meter, we're going to need to look at the back of the conductivity meter. Now let me go grab a conductivity meter. We saw these when we did our lab with conductivity and when we were talking about the solids. And there's a switch on here, you just make sure that it's on. Nothing should light up because air doesn't conduct electricity. But if you were to squeeze these 2 little pins together, you would see it light up bright, right? Both of them kind of light up bright there. Now that's because it's metal and metal touching, and metal conducts electricity really well, right? So if we take a look on the back, the way that we kind of like explain the brightness is using this chart. So here's our scale. So you're going to have numbers for what you put in here. And you get the numbers from if the red light and the green light are on, and if you think they're dim or they're bright. So it's kind of subjective. It's not perfect, but it's okay. We can kind of come up with an idea. And because you guys will be comparing all of them, you'll be able to figure out where they match. And that's today's goal, is to figure out where it matches. So on the back, and you can see, even on the front here, here's the red and the green, so they're lit up. If the red lights up very bright, and with the two metal pieces, that's pretty bright. The green's a little dimmer. It's harder to light the green up. Green's medium. Okay, so very bright and medium. The conductivity is very high. It's a 4 on our scale. Okay, so that's what we would write in here. All right, so we would say, if that was really bright, if we had metal on here, we'd say, number 4, very bright. So I would write down both of these so you remember what the number means. So the 4 and then the very, very high. All right, when you do that. And this is on the back of every one of them. So you'll have this chart on there. All right, so that's how we use this scale. And again, you'll have information for all of these. You'll compare it with this one, and you'll be able to figure out which one of these is the same as acetic acid at 1 molar. All right. Now, the actual lab, how are we going to do the dilution? This doesn't look pretty, but it's basically how we're going to do it. In these 2 wells, so you'll get a micro well plate. In these 2, you're going to put 20 drops of each. So 20 drops of hydrochloric acid, 20 drops of the 1 molar acetic acid, just into this one. I didn't mean to circle all those. And you're only going to dilute, we're only going to dilute the hydrochloric acid, all right? So we're not going to dilute the acetic because we don't need that. We're just going to compare this 1 molar acetic acid with all of these ones down here, all right? So we have our hydrochloric. We're going to take 2 drops of our hydrochloric acid and put it in here. We're going to add 18 drops of distilled water. We'll mix it up just like we did before, all right? And then we use our dropper bottle to take 2 drops from here, 2 drops into here, 18 drops of water, mix it up. Same thing, same thing, same thing, same thing. Last time we did this, we did 9 drops and 1 drop to make 10. We're just doubling it just so we have more solution, so that we can make sure that the conductivity meters can actually get in there and fit, all right, so that it lights up, all right? And then that's it. Once you have this all set up, then you're going to put your conductivity meter into each of these, rinse it off in between each sample, just with the squirt bottle with a little distilled water, all right? Go in there, test it out. When you're done with it completely, after you've used this completely, then put a drop or 2 of universal into each of them, all right? Because we don't want to put this into universal. We'll do that at the very, very end. All right, and that'll give us our data, and then we're basically going to talk about what our data means. Any questions with that?